At time t seconds, a particle p has position vector r with respect to a fixed origin. R is a two-dimensional vector here. At time t seconds, p is moving in a direction parallel to the vector r minus I minus j. So -1 in the I direction, -1 in the j direction gives a vector like this. And so if two objects are moving in a parallel direction, their velocities are parallel. So the velocity of this one will be a scalar multiple of this original vector. So let's say k and minus I minus j. So I'm going to find the velocity, or use the velocity in order to find the time. And this isn't a constant acceleration question. There's no mention of constant acceleration. So I'm going to use the variable acceleration method, which is to differentiate. If I differentiate the vector that is related to displacement, the position vector, then I get velocity. So that will be 3t squared minus 9t minus 24i plus minus 3t squared plus 6t plus 12j. And that, as I've said, is equal to a scalar multiple of minus I minus j. So by equating coefficients in the I direction and the j direction, I can obtain two equations. So 3t squared minus 9t minus 24 in I is equal to minus ki. And for j, minus 3t squared plus 6t plus 12 is also equal to minus k for j. So I want to eliminate k because I'm trying to find t. So if I subtract that second from the first, 3 minus minus 3 is 6t squared minus 15t minus 36, and that equals 0. So to factorise this, I'm going to make my life easier by dividing through by 3 first. And now I'm going to factorise it. And in these questions, they're nearly always factorisable. 12, well, if I use 3 and 4, 3t and 2 times 4 is 8. So that would work, and that's negative and that's positive. So t is equal to minus 3 over 2 or 4. This can't be right because t is greater than 0. So the answer to part A is t equals 4. For part B, the magnitude of the acceleration at p at the instant when t is capital T that was found in part 1 when t is 4. So I need to differentiate velocity with respect to time to find acceleration. And so differentiating the velocity, I'll get 6t minus 9i plus minus 6t plus 6j. And at t equals 4, 6 times 4, 24 minus 9 is 15i and minus 18j. Now it asks to find the magnitude of the acceleration. So that to find the magnitude of the vector, we need to use Pythagoras. So 15 squared plus negative 18 squared, and that's equal to square root of 549 or 3 root 61 or 23.4 if you're doing that to 3 significant figures. Marks wise, there's a method mark for clear use of differentiating to find the velocity here, and then a method mark here for obtaining two equations for the I and the J components, and that's a DM dependent mark, dependent on showing this working. There's another method mark for solving the equation, and a final accuracy mark for finding t equals 4. In part 2, there's a method mark for clear use of differentiation to find an equation for acceleration, and an accuracy mark for all terms correct. So the method mark, all terms must be included, but there may be some sign errors or some coefficient errors. The accuracy mark fully correct. Then a method mark for expressing that as a vector by substituting in the value that you found in part 1, even if it wasn't 4. Then another method mark for clear use of Pythagoras to find the magnitude, and an accuracy mark for the final answer correct.